Okay, so today we're talking about Chapter 7, Section 3, Quadratic Equations, Functions, and Inequalities. Wait, no. Equations in quadratic form. Read the wrong thing. So equations in quadratic form. Alright, so up to now, we've had different methods of solving quadratic equations. Of course, we did it by, we know that we can do it by factoring, by completing the square, and by the quadratic formula. Okay. In this particular case, we're going to ramp that up just a little bit and get some pretty complicated, I won't say complicated, but what am I trying to say? We're going to try and relate equations to our quadratic equations that we've seen. Okay. Now, let's go ahead and put this on the notes. Of course, we're basically going to go over this example, but we'll just put that on the notes and we'll talk through the example, which pretty much is this, which pretty much reiterates that. But I'll put it in my own words because that's what I get paid to do. Alrighty, so this reads, solve the equation. So looking at this equation, it looks complicated, right? It looks like it is not a fun time. And, well, it's not going to be a fun time, but it's not going to be nearly as bad as you think it is, right? So what we need to do is we need to look at this and, first of all, we know that quadratic equations are in the form ax squared plus bx plus c is equal to 0. And, well, this particular equation, believe it or not, is in that form. Okay, how is it in that form? Well, let's rewrite it real quick to really see. Um, how should we do this? Let's color coordinate like this. Okay, so maybe this might help you see that in this particular equation, right? Let's just say that let's have a be 1, right? Because it technically is, but let's just put 1 there, right? We can see that this is definitely in the form of ax squared plus bx plus c, right? It's just in this particular case, the x term is 2x squared minus 5. So that's what we're going to do. We're going to do some substitution here, and we're going to pretend just for a little bit that the 2x squared minus 5 is going to be the x. Okay, so let's do the equation here and just do a little bit of pretending. So we're going to pretend it's the x, but let's use another variable here. Okay, let's use the variable u. U is going to be equal to 2x squared minus 5. So 2x squared minus 5. Okay, so now I can rewrite this equation as something that looks like this, as u squared minus 16u plus 39 is equal to 0. Okay, so now we're able to uh, rewrite it as so, and then u squared minus 16u, and let's fix this u up a little bit. It kind of looks like a half-drawn a, so that does too. All right. We can factor this into, looks like, uh, 39, 13, 26. Yeah. Okay, so we can factor this into u minus 13 and u minus 3, and that's going to be equal to 0. So this tells me I've got u is equal to a positive 13 and u is equal to a positive 3. Okay. Now, this isn't the end of the story, though. Okay, because recall that I said at the beginning, I said u is equal to 2x squared minus 5. Okay, so that u is going to take the place of this u down here for both of them. All right, so let's go ahead and proceed with that. And let's put a little dividing mark here. Hopefully this is enough space. Okay, so now what we're going to do is we're going to say the u, we said u was 2x squared minus 5. All right, and that's going to be equal to a 13, And then we also have a second one, and hopefully I can solve that in that little space. So 2x squared minus 5, and that's equal to 3. And I meant to write 13 up here. Okay. Okay. And then if we solve for this, we're gonna do a little bit of mental math for this because I want this to fit. So we add 5, divide by 2, so that becomes what, 18 over 2 is 9, and the square root of plus or minus 9. So it's gonna be x equal to plus or minus 3, plus or minus 3. Same thing over here. We're going to add 5, so we get to 8. 8 divided by 2 is 4. Square root of 4. So it's going to be x is equal to plus or minus 2. Right? And those are our solutions to this problem. And the again, the hard part in this particular case is knowing what to let's see, is knowing what to substitute here. Okay, we substituted 2x squared minus 5 in for our x, and then we solved. And then once we solve for u, remember that means the original problem didn't have u's in it, so we can make them, well, so we have to turn them back into x's by equating u, because again, let's just, you probably grasp this idea, but just in case, we said u is equal to 13. Well, what is u? Well, u is 2x squared minus 5, and that's what we did over here. 2x squared minus 5 is equal to 13, and 2x squared minus 5 is equal to 3. Because down here we say u is equal to 13, u is equal to 3. Right. So another example, excuse me. Um, well, yeah. Alright, so we've got p to the 2/3 minus p to the 1/3. Now this looks like it's going to be some trouble, but again, what we're going to do is we're going to just make a little substitution. Okay, we're going to say that u is going to be equal to p to the 1/3. Okay, now in all these cases, notice how the variable that I choose, and the variable that we use is generally u, and it's going to be pretty much equal to the middle term every single time because we can always square u to get to the first term. Okay, and that's, of course, that's what we did here, squared u to get to the first term. So we're going to do this again. We're going to set u equal to what that middle term is. The middle term in this particular case is a 1/3. Okay, so I'm going to say u is equal to p to the 1/3. Okay, now I'm going to rewrite this equation. I'm going to go ahead and put the 8, pull the 8 to the left side here, from over here to over here. We're going to pull it to the left. So we're going to end up with a p to the 2/3, I'm sorry, u squared, I lost my train of thought here, u squared minus 2u is equal, or minus 8 is equal to 0. Again, let's just recap this. If I squared u here, right, I would get u squared is equal to p to the 2/3, which is what this is. Okay, so that's why we make the substitution pretty much for that middle term, right? Because u is equal to p to the 1/3 in this particular case. And so the difference between this equation and this equation is nothing really, as long as we denote that u is equal to p to the 1/3. Okay, and then from here it looks like 4 and 2, so we can say u is minus, it's like minus 4 plus 2, u minus 4, u plus 2 is equal to 0. So we've got u is equal to a positive 4, and u is equal to a negative 2. Okay, so we have a positive 4 and a negative 2, but again, this is in terms of u. We didn't start the problem in terms of u, so we have to make the substitution back. Well, u is equal to p to the 1/3, so I'm going to say p to the 1/3 is equal to 4, and p to the 1/3 is equal to negative 2. Okay, so p to the 1/3 is equal to 4, and p to the 1/3 is equal to a negative 2. Okay, well, looking at this, p to the 1/3 we know is just basically the cube root of p, right? So let's just go ahead and rewrite that as the cube root of p on both of them. Okay, and it'll become abundantly obvious why here in a moment. Okay, well if we have the cube root of p is equal to 4, how do I get rid of that cube root? Well, I cube both sides, right? So if I cube both sides, I end up with p is equal to, what is 4 cubed? Well, 4 cubed is going to be 64. And what is what is negative 2 cubed? All right, so p. And then what is negative 2 cubed? Well, negative 2 cubed is a negative 8. And so that is my solution. P is equal to 64 and p is equal to negative 8. All right, I think it's a pretty short section, yeah. So we're already almost halfway. All right, now square roots. Now we're not a big old fan of square roots now, are we? But we're going to solve this the same way we solve our other problems. Okay, so how do we go about doing this? Well, looking at the problem, we know that the square root of x is just going to be x to the 1/2, right? So x to the 1/2 is going to be our u. Okay, and from here we can now rewrite this as u squared minus u minus 12 is equal to 0. And it's 4 and 3, so it's going to be u minus 4 u plus 3, and therefore we have u is equal to a positive 4 and u is equal to a negative 3. Okay, so we have u is equal to positive 4, u is equal to negative 3, and then we're going to equate them again. All right, so u is equal to x to the 1/2, and again, let's just go ahead and write the square root of x just to keep it simple. So we have square root of x is equal to a positive 4, and the square root of x is equal to a negative 3. And let's move that down just a tad. So square root of x equal to 4. That means that I square both sides. Okay, this is interesting. So, okay, so we square both sides, so we're going to end up with a 16, x equal to 16. Okay, all right, but we have a problem here. We have a problem on this one, right? The square root of x is equal to negative 3. I mean, yes, you could go about solving it, right? But you're gonna run into issues here. Instead, we know that there is no x value that when I take the square root of it, I will get to negative 3. Okay, so this does not have a solution there. So the solution is only going to be 16. Oh, this one looks awful. Oh, this looks terrible. Okay, well, here we go. Here, calm down, breathe. Here we go. So we'll just go ahead and start. I said that we can just set up the u being equal to whatever the middle variable is. The middle variable here is x squared. Okay, so now I can rewrite this as 4 u squared plus 7u minus 2. That's going to be equal to 0. Okay, so I need to be able to factor this, and can't really factor this in my head. I mean, yeah, let's see. 8. Yeah, I can. I can, but just in case you can't, let's do this, kind of the long way, right? Because I mean, obviously I've been doing this a long time. I can't get around to factoring this, but let's do this the longer way. We're gonna do the AC method. Okay, so pay attention, follow along because I'm going to erase it when I'm done. Okay, so the AC method, A times C. My A value here is 4. My C value is negative 2, so I have negative 8. All right, but I'm going to take the absolute value of it, so I'm going to get to 8. So my factors of 8 are 1 times 8, 2 times 4, and then 4 times 2, but we've already said that. So 1 and 8 and 2 and 4. So of these, only these two factors, which one will give you a positive 7? Well, it looks like a positive 8 and a negative 1 will give me a positive 7. So what I'm going to do is I'll rewrite this as, rewrite it down here so I can just erase it easily, with 4u squared, and then we're going to have a, what did I say, plus 8, so plus 8u, and then a minus 1 minus u minus 2 is equal to 0. And again, notice how 7u is the same, I mean, all I did was just split it up, right? That's all I did. It's kind of like saying negative 2 is minus 1 minus 1. Right? All I did was split that 7u up into an 8u and a negative u. Anyways, from here, we know that we can factor by grouping. And if I factor by grouping, the left side, I can factor out a 4u. And what remains, it looks like a u plus 2. I'm going to factor out a negative 1 over here to get a u plus 2. And these are my factors, right? So my factors are just going to be 4u minus 1 and u plus 2. Okay. Let me erase that now. So this tells me that I've got u is equal to 1/4, so u is equal to 1/4, and u is equal to a negative 2. All right, but we're not done, because again, my u that I had over there, up here rather, was u is equal to x squared. Okay, so I'm going to end up with x squared is equal to 1/4, and x squared is equal to a negative 2. Okay. Solving for this, I take the square root of both sides. I've got x is equal to a 1 plus or minus 1/2, and I've got x is equal to a plus or minus I on the square root of 2. Okay, and that's it. So that wasn't too terribly bad, but that's how we do that problem. And it looks like the last problem we have for the day, solving rational. Oh gosh, this looks horrible. All right, well, just got to get to it. All right, so again, hopefully, hopefully by now you can tell that I'm not too far different than you guys, because I see this problem and I just get such a sense of dread, because I know what all we have to do, and as you do these problems, you're gonna know what to do, and you're just gonna be like, ugh, this is awful. But that's part of it, right? There's gonna be parts of school and your job, your future, that you're not gonna like, but you have to do. So I'm gonna get off my soapbox for a moment, and let's go ahead and let's get rid of the denominators here. Okay, so how do we get rid of the denominators? Well, we need to multiply both sides by the least common denominator. All right, so let's write that. How should we write that? We'll do it like this: 3. Okay, it's probably gonna be a 2-pager. Okay, so we're gonna multiply this entire problem by my least common denominator, which is y plus 2 and y minus 1. Okay, so we're multiplying the entire problem by that. So if we distribute here, we're going to end up with a 3y. The y minus 2's cancel, so we're going to have 3y times y minus 1. And then minus, we're going to distribute here. The y minus 1's are going to cancel, so we're going to have 2 times y plus 2. And then it's going to be equal to just simply y plus 2, y minus 1. Okay. Well, we're going to have to clean this up a little bit, and so we're going to end up with, looks like 3y squared minus 3y minus 2y minus 4. Then we're going to FOIL this. We're going to have y squared. It looks like we have a 2y, and then negative 1, and then so it's going to have a plus y. And then we're going to have negative 2. Excuse me. Okay, so we're going to move everything to the left side, and we're going to end up where we're going to subtract y squared from both sides. We're going to subtract y from both sides. We're going to add y to both sides. So the left side, we're subtracting a y squared, so we're going to end up with a 2y squared Let's make that squared a little bit smaller. And then if we combine these like terms, let's say negative 5y, and then we subtract a y, so that's going to be minus 6y. And then we have a negative 4, we're going to add 2, so we have the negative 4 here, we're going to add 2 to both sides, so we're going to end up with a minus 2. That's equal to 0. And let's, I can memorize that, that's not hard. 2y squared minus 6y minus 2 is equal to 0. Ooh. Sorry about that. Well, we got alarms going off all over the place. Let's cut that off. So, shoot, I don't know what I was saying. So we've got 2y squared minus 6y minus 2. So we've got 2y squared minus 6y minus 2 is equal to 0. We can factor this. Before we factor, let's just go ahead and divide everything by 2. If we divide everything by 2, we end up with a y squared minus 3y minus 1. And now it's, is it easy to factor? Well, no, it's not actually easy to factor. So we're going to do the quadratic formula here, because I can't factor some, I mean, we can't factor this at all. So we're going to need the quadratic formula. So we're going to do a negative b, so negative 3, plus or minus the square root of b squared, which is negative 3 squared, minus 4 times a, which is 1, times c, which is a negative 1, all over, and again, this is x is equal to, all over 2a, which is 2 times 1. And let's put this into our calculator here. All right, one moment. I don't think that's entirely too right. All right, so we're going to end up with a, oh man, looks like x. Okay, I said x, but this is actually a y, isn't it? Yeah, so let's go ahead and change that x over here. I'm afraid that probably won't show up on the notes, but oh well. What the heck? Y. Okay, y is equal to, we're going to have a 3 plus or minus the square root of 13 all over 2. Okay. And then from here, well, that's it. That's actually just the solution set. Nothing too crazy there. Let's see. What do we do? Yeah, we actually didn't even have to do any substitution or anything there because it was just a normal problem that we've seen before. Anyways, that concludes today's lecture.